How's everybody doing tonight? You know, I had in my notes here, and I completely forgot about it, left them up here. I was going to mention that if you have a smartphone, that there's a couple of apps that you might want to consider that really don't use a whole lot of data. And what data is a big thing, right? Use too much data and you got to pay for it. Nobody likes to do that. But one of the things that I see Rick's coming in here, I think. So I'm gonna take advantage of this little window of opportunity that I have here. Audioverse. Audioverse is an app that you can get. It's a Seventh-day Adventist app. It's Audioverse is hosted by UT Pines. Oh, not UT Pines. I'm sorry. It's Ouachita Hills. Ouachita Hills College and Academy in Arkansas. And they compile sermons and presentations from GYC, Michigan Conference, all over the place. And you can search. So if you're looking for a specific topic, you can search for those topics using this app. And you can hear Mark Finley, and you can hear so many people. It's just really, really good. Audioverse? Oh, yeah. Yeah. Yeah, it's very cool. It is very cool. Hope Channel app, that takes a little more data because you're going to be streaming video. Okay? But the audio is not a whole lot of, doesn't take a whole lot of bandwidth or data. So it's not a whole lot worse than listening to voicemails for a period of time. But keep that in mind. And then AFTV, which is Amazing Facts TV, is another one. It has Proclaim, Dare to Dream, Amazing Discoveries, all in that one app. And it's really, really cool. I kind of go back and forth between watching all of those. And then if you're not subscribed, you can subscribe and get the glow tracks, right, out there on the wall. You can get the newsletter, which tells stories about people who are getting glow tracks and their experiences, and you can sign up. It's I can't remember if it's glow.org, but we can look that up. But oh yeah, there's all kinds of neat stuff out there to encourage you, to show you that God is moving and working, and some awesome stuff. And then Amy wanted me to mention too that she has gotten an update on the Country Life food order, and March 5th is the deadline for ordering. So if you want to take advantage of the Country Life Natural Foods catalogs and everything that they have to offer, dates. I'm eating dates, right? Whole dates. Man, those things are awesome. Got a big bag of dried pineapple, dehydrated pineapple. Awesome. All that good stuff. It's all available, but if you want to get in on that, March 5. That's the only book I brought. Pretty much. Not a lot of time, is there? Not a lot of time. Excuse me. So, I don't have a lot of songs picked out. I just flipped to one, and there it is.
Sign Landry for a book.
Okay. He's signing. That's good. I like that. Oh, awesome.
She took it, and then it's like,
Thank you.
she took it. She just had it.
Well, why don't we kick things off here by starting with hymn number 462.
Start with prayer already.
Yeah, we should have a prayer, but we'll let you turn in your hymnal. 462, Blessed Assurance. And, would you like to do the honors for that?
Let's bow our heads and we'll have opening prayer. Our kind Heavenly Father, we thank you again for your blessings of another Sabbath day that you've given to us. May you be with us this evening and give us a spiritual blessing. I ask these things in Jesus' name. Amen. I don't think this will help me, but... Blessed assurance, Jesus is mine. Oh, what a foretaste of glory divine, heir of salvation, purchase of God, born of His Spirit, washed in His blood. This is my story, this is my song, praising my Savior all the day long. This is my story, this is my song, praising my Savior all the day long. Perfect submission, perfect delight, visions of rapture now burst on my sight. Angels descending, bring from above echoes of mercy, whispers of love. This is my story, this is my song, praising my Savior all the day long. This is my story, this is my song, praising my Savior all the day long. Perfect submission, all is at rest. I in my Savior am happy and blessed, watching and waiting, looking above, filled with His goodness, washed in His love. This is my story, this is my song, praising my Savior all the day long. This is my story, this is my song, praising my Savior all the day long.
Okay. I'm going to flip and attempt to find another hymn that I actually have taken the time to work out the chords for. You know how that goes. I can't find them once in a while. I do stumble on them. I didn't get a chance to put bookmarks in. I did, however, get a chance to go see my dad this afternoon. Praise the Lord. And he's doing well. I can't say that he's enjoying his experience in the nursing home, but he's doing well. And it's good to see that, you know, even though sometimes the mental function fades a little bit, right, as you age, but there's still enough of his personality and sense of humor there that we could have a good visit today, and it was a real blessing.
Amen.
It was a real blessing. Timing on this one. Guitar.
This is 327, just in case you're wondering. I'd rather have Jesus. This is 3/4, so that's
you know what? That clock back there on the wall still says that it's 22:11.
That's
We got lots of time.
We got all the time in the world at this rate, right? Man. Oh, that bit me once. Keep me on track tonight, will you? Anyway. You got one there? Awesome.
The Sabbath, the time stood still.
The time stood still. Right? It worked in the Old Testament.
Yeah.
Well, Scott,
Once.
you gotta keep looking outside. When it gets dark, it's time to quit.
There you go.
Yeah. Until the pastor or evangelist brings up, Paul preached all night.
Yeah.
Right?
What about that?
But we say temperance in all things, right? Yeah.
Amen.
530. It is well with my soul.
Amen.
C6, sorry. No.
Just by C or C7.
Okay. When peace like a river attendeth my way, when sorrows like sea billows roll, whatever my lot, thou hast taught me to say, it is well with my soul. It is well with my soul. It is well with my soul. My sin, oh, the joy of this glorious thought. My sin, not in part, but the whole, is nailed to the cross, and I bear it no more. Praise the Lord, oh my soul. It is well with my soul. It is well with my soul. And Lord, haste the day when my faith shall be sight. Those lines he wrote back as a scroll. The drum shall resound, and the Lord shall descend. Even so, it is well with my soul. It is well with my soul. It is well with my soul. Woo, you guys sound
Ooh,
good.
amen.
They sound good, right?
Amen.
You know, that's the way a hymn's supposed to be sung, with enthusiasm, right? These aren't lifeless hymns, like we talked about today. When you feel a temptation coming on, this is the lifeblood of how we kind of fight some of those temptations off,
Amen.
right?
Well, that's, yeah, great.
You know, Jesus paid it all. 184. Jesus paid it all. 184. I hear the Savior say, "My strength indeed is small. Child of weakness, watch and pray. Find in me thine all in all." Jesus paid it all to Him I owe. Sin had left a crimson stain, He washed it white as snow. Lord, now indeed I find Thy power and Thine alone can change the leper's spots and melt the heart of stone. Jesus paid it all to Him I owe. Sin had left a crimson stain, He washed it white as snow. Since nothing good have I Thy grace to claim, I'll wash my garments white in the blood of Calvary's Lamb. Jesus paid it all to Him I owe. Sin had left a crimson stain, He washed it white as snow. And when before the throne I stand in Him complete, I'll lay my trophies down, all down at Jesus' feet. Jesus paid it all to Him I owe. Sin had left a crimson stain, He washed it white as snow.
Boy, you ever have the words just get to you when you're singing?
Amen.
Man, for some reason that one tonight just really, I don't know. And then y'all are singing, you know, you're singing out and I hear harmony and I hear everybody singing together and it's just, boy, that's a little bit of what heaven's gonna be like, right?
Amen.
The choirs, right? The beautiful music, all in unity. All in unity.
Amen.
That's gonna be beautiful.
I'll be on the guitar.
Yeah?
That was my wish, always
Really?
to play guitar, yep.
No kidding.
So I guess I'll just wait till I get to heaven.
Says we'll have a heart, right?
That's
Bible
pretty
says we'll
close.
have a heart, but I've read in the Spirit of prophecy where the saints of God all strike a chord together in unison at the same time,
Wow.
and the courts of heaven ring. Can you imagine? So for now, we'll sing on together here, right?
Amen.
For now, we'll just keep doing what we do and praise the Lord in how we do it, and that's what we'll do.
Yeah, it's a
I don't know that it is. You're right.
They probably don't have
I don't
parts
think
of
that
that.
it is honestly.
That's a beautiful.
We could do at least a verse. We can do these two verses, right? Because I think most
Okay.
people know those.
Okay.
Okay, so it's not in the hymnal. mansion over a hilltop.
Okay, that's not in here.
And I think everybody pretty much knows about 2 verses, and if you don't, this is a good time to learn them. Okay? That good speed? Good tempo?
I'm satisfied with just the cottage below, a little silver and a little gold. But in that city where the ransom will shine, I wanna go on that silver line. I've got a mansion just over the hilltop in that bright land where we'll never grow old. And someday yonder we will never more wander, but walk the streets that are purest gold. Don't think me poor or deserted or lonely. I'm not discouraged. I'm heaven bound. I'm just a pilgrim in search of a city. I want a mansion, apartment of crown. I've got a mansion just over the hilltop in that bright land where we'll never grow old. And someday yonder we will never more wander, but walk the streets that are purest gold.
Amen. A harp and a crown.
That'll be cool, won't it? If I can use that word, that'll be cool.
Amen.
Okay, trying to think of. You got another one?
Yeah, but you can look for one. I can come up
It'll
with
take me a while.
Let's do 312 near the cross. 312.
Good tempo. It'll be swing. You can do a strong beat and back me up, right? What?
You can do a here, down one, and a down one.
Top fret, top fret.
Up one fret. Well, down actually.
It is?
Well, up is this way.
You sure you want to play the guitar, Linda?
No, I changed my mind
Or
to
you
a
can do it
harp.
up here. Yeah, there you go. And alternately, you can do
Harp and a crown.
this. And just play one of the strings. Or you might do B7, that might sound okay too. Where are we at? Oh.
And there's a G sharp 7. I'll
So-
sing.
C.
I gotta give Rick a lot of credit for knowing all the chords. following the words, playing the chords, and the chords aren't on all of the verses that we're singing with.
Yeah, so you gotta go between them.
And sing
That's
in
why you
harmony.
get a hymnal and you write the chords in your hymnal, and then you just take your hymnal wherever you go.
And I started,
I have it in mind.
Yeah.
I said you're hired.
And
Don't
that's
you
what
think
she's
that-
trying to tell
don't you
you.
think the Seventh-day Adventists, the Conference of Seventh-day Adventists ought to put out a book with all the chords in it?
Yeah, it should.
Amen.
Look in the camera and say.
Maybe it'll gain momentum.
Anybody watching?
Yeah, look in the camera and say that.
Oh, yeah. Brother Mitchell, if you're watching me, from the bottom of my heart, would deeply appreciate chords in the book for all of these hymns. Oh.
And in normal, easy keys.
Yeah.
Okay, we
Right,
got
let's
it.
go. Jesus, keep me near the cross, there a precious fountain, free to all a healing stream,
wants to endure it here tonight. I bowed out on a lot of those chords.
You guys sound great.
Oh, yeah.
We appreciate the help of it.
And it's a lot of fun though, too, isn't it? Right? I think as a culture, we're kind of getting away from singing together. Just sad, I think something's lost there.
And singing the good hymns with the real messages.
Real words.
Yes.
Real words. Let's turn back to 195, Showers of Blessing, 195. Is it an E or F?
It's a B7.
F sharp minor 7.
F sharp. You know how we said the message is supposed to be really simple today? I wish the chords were sometimes. But we'll get through it.
See, you're learning today.
Yeah. Okay. There shall be showers of blessing. This is the promise of love. There shall be seasons refreshing, sent from the Savior above.
town of Keystone,
Joe, hold on a minute.
surrounded by the beauty of the Colorado mountains. When you
Christy's son's missing. And they called me and they said, "Where's Zachary? Is he with you?" I said, "No, he's not with me. He's not there." And they checked where he usually goes. He only goes either to the library, to his friend Pat's house, and he's neither of those places.
Why don't we have prayer with Christy right now? And then if you need me to take you home, I can run you home and then watch the video if you need. Okay. Can we pray with Christy real quick? Let's come into the middle, Christy. Scott, you wanna pray?
Father in heaven, we pray right now specifically for Christy's boy. And we already know that you care more about him than even any of us could. And we know that you want the best for all human beings. Knowing this, and knowing that we're supposed to come to the throne boldly, we do so now, and we ask that you will please locate him safe and sound, and that you'll do it, Lord, within just a very short period of time. You can do anything. We pray, Lord, that our faith will be strengthened here, Christy's faith will be strengthened, and that in the end, you will find her boy. And we just ask, Lord, for patience and for faith as we move forward and we do the part that we need to do to get in touch with him, to go seek him out. So we pray to send your angels before us as this happens, and that he will be safe. We thank you, Lord, for hearing our prayer, and we pray in Jesus' name.
Amen.
Not right now. I'm gonna take Christy home to find her boy.
you look at beauty like this, do you ever wonder where it all came from and how it got here? In the late 19th century, an English naturalist named Charles Darwin put forward a theory. He suggested that all of this beauty, the trees, the flowers, even us, all came from a cosmic accident. He theorized that over time, all of this life and beauty simply evolved. But was Darwin right? Today, evolutionary theory continues to be taught as fact in our institutions of higher learning. But to be fair, Darwin himself had real doubts about his own theories. In the next few minutes, I want to introduce you to some incredible creatures that defy evolution. Darwin was fascinated by animals, and many of his theories came from studying them. Today, we've uncovered some incredible facts about these creatures that Darwin simply never knew. I'd like to introduce you to Dr. Job Martin. For the past 20 years, Dr. Martin has been fascinating students all over the country as he shares his findings on these incredible creatures. Dr. Martin has had an extensive education and a varied career. During the Vietnam era, he served President Johnson aboard Air Force One as part of the 89th Military Airlift Wing. Later as a dentist, Dr. Martin became a university professor and was a committed evolutionist. But his traditional scientific education would soon be challenged when he was exposed to some of these incredible creatures.
Actually, I began to look at animals when I was a professor at Baylor Dental College, and two of my students had challenged me as a result of my first lecture. I gave my first lecture on the evolution of the tooth and how the fish scales migrated into the mouth and became teeth over thousands of years. And two of my students challenged me after class. They said, "Dr. Martin, have you ever investigated the claims of creation science?" And so they wanted me to study some animals. I was a biology major in college, and I had never thought about the animals in a creation type way. I just thought of them in terms of evolution. So we started looking at some animals, and I started giving some thought, and we've already shown some of those in Volume 1 and Volume 2 of the incredible creatures, like the bombardier beetle and the giraffe. They were some of the first ones I studied. And I began to realize there's absolutely no way this particular creature could evolve everything that it has. There's not enough time, among other things, as well as where does the information come from? Because chemicals don't have information. A chemical is a chemical. And so I was thinking, okay, how do you get the information into the genes? Because if we're going to have evolution, we've got to have information coming in there from somewhere. But yet you can't add information genetically. Information gets dropped out, but it doesn't get added in. And so over a period, actually it took about 5 years. My wife would tell you for 5 years, my stomach was churning, and I was thinking, this can't be right. Surely there's some way to explain this in evolutionary terms. I just couldn't find any way to explain it. And I searched the literature, and I finally came to the conclusion, it looks like this thing was designed and made by some supreme power, and it began to move me from being a committed evolutionist to being a convinced creationist.
So here we go. Our first incredible creature is none other than the lowly mussel. Not this kind, but this kind. These mussels live in quiet rivers and streams all over. And while these little guys don't look like much, they have an amazing skill to survive. You see, in order for these little guys to reach adulthood, they have to spend part of their lives, almost 6 weeks, in the mouth of a host fish, like a bass or a trout. And you thought you had problems growing up. How do they do that? Well, here's Dr. Martin to explain.
It's called the Lampsilus mussel, and it mimics different minnows or shiners or little tiny fish, and there's a reason for that. So here you have this little mussel, and it closes up almost all the way, and then it pushes its soft tissue out, and in the soft tissue it looks like a little minnow. And now some of these are specific to a particular fish. They have to have a particular fish come down to eat that particular minnow. And so there is one that it mimics a little minnow that will attract a bass, like a largemouth bass. And so it's down here, and it'll give jerky little motions, and that seems to attract the bass. And the bass will come down, he'll look at that, and he'll think, that looks like a good lunch. And he'll go and open his mouth to grab that bait that this little mussel has produced. And the split second that he opens his mouth to grab the bait, the mussel opens up and shoots its larvae and eggs up into the mouth of the fish, in this case the bass, and those little things from the mussel will attach to the gills in the bass, and that's where they live as a parasite. or maybe it's a symbiotic relationship, but they drink the blood from the fish, from the gills, until they get big enough to drop off, and then they grow. Well, now here's some questions. How does a little mussel, like a little clam-like thing, how does it mimic a particular kind of motion, like sometimes jerky motion? Some of them, it looks like they're gulping air. They have a little mouth, it looks like it's gulping air. Others have a different artwork on the body, a different painting, so to speak, so that they mimic a particular type of a little fish. How would evolution explain that? They have to know the right fish to shoot their larvae or their eggs up in there. And so, how do they know what's the right fish? If it has to be, let's say, a largemouth bass, then that is the fish that this little mussel has to find. You don't think of a little thing like that having a very instant action like it needs, because when that fish opens its mouth, and we know how fast a fish will take the bait. When a fish goes to take the bait, it's like, oh, just a quick little thing and it's got it. Well, the very split second that that thing opens its mouth, that other fish, boom, the mussel opens and shoots. So the timing is crucial. It has to have its timing worked out, but you don't think of something like that, of having that kind of an instant reflex. I mean, you think of a clam or something down on the bottom of a stream, or it's just kind of there, kind of opens and closes a little bit, but this is amazing. So let's think about this in terms of evolution for just a minute. First of all, how would it evolve exactly the right little minnow type thing here? How would that happen? And then if somehow it did, how would it know what to do with it? How does evolution explain that? What would be an evolutionary explanation for that kind of a thing? I can't imagine. I can't imagine how just mindless, random chance processes is going to come up with such an amazing harmony and unity here that we need, because if it doesn't work, if this little mussel doesn't shoot its larvae, let's say, up into this fish to attach to the gills, it goes extinct. So it has to have happened for the very first one, because that is their reproductive mechanism. And if it didn't happen with the first one, with the right fish at the right time, with the right reflex, and all of that happening all together, it goes extinct. I don't see how evolution can explain that.
Wow, the Lampsilis mussel really does defy evolution. Amazing. Whoa! Oh, great ride. Wow, horses are amazing animals. They are fast, they are powerful, they are our next incredible creature. Did you know that horses were domesticated over 3,000 years ago? In fact, they helped change the course of history. Since the beginning of time, horses have been one of man's best helps. Armies like the Romans used horses to a tremendous military advantage. The Greeks used horses for the first Pony Express, and the Chinese invented the saddle. When Christopher Columbus landed in America, he introduced the American Indians to the white man's big dogs. For the American Indians, horses soon became an essential part of their way of life, helping in the buffalo hunts. For years, the horse was the only reliable transportation in most of the world. Horses are our next incredible creature. Through breeding, men discovered that they could combine different horses and could create horses with different abilities. Workhorses, horses to pull carriages, or ponies for kids, and horses could be bred in all sizes. The largest horse ever bred was over 7 feet tall in the swayback and weighed over 3,000 pounds. And the smallest little horse was only 14 inches tall and weighed only 20 pounds. Yet, with all these varieties of breeding, they still bred horses. They didn't get cows, they didn't get monkeys, they didn't get pigs, just horses. Horses have some other amazing attributes. Come on, let's go. Come on. Carol, let's go. Come on.
God made the horse in a very special way. Its heart, for the body size, it has a small heart. And the heart is really not enough to efficiently and effectively pump the blood throughout the whole system of the horse. And so the horse has 4 auxiliary pumps. It has 4 extra little pumps. And those pumps are its hoofs. Now, the hoof of a horse, if you kind of turn it up and look at it at the bottom, it has the hard part of the hoof around the outside, and then in the middle is this V-shaped soft tissue. It's called the frog, and when the horse steps down, it compresses that soft part, the frog. And when it compresses that soft part, it pushes up against a series of mechanisms inside the hoof, which pushes against the veins, and that squeezes the blood up the leg. So whenever a horse is standing still, like in a stall, and it's not moving for a long time, it can go lame. And usually it'll go lame first in its hind feet. Because if a horse wants to look at something, it'll move its head, but then it'll move its front feet a little bit too. It'll lift a foot and move it. So it's pumping a little bit here, even just moving around like a little piece of hay over here it wants to pick up, but it won't move its hind feet. So they just stay there. So the blood begins to pool in the hind feet because it's not moving them up and down and pumping them. And so what do we have? We get lame many times in a horse. Now, when they run, now they need extra energy. And so when they start running, now they're really pumping hard because their hoofs are coming down, and it's that extra shooting that blood up the legs to help return them. And then when it lifts its foot up, that relaxes that, and the arterial blood then shoots back down in there, and so it just keeps the blood circulating around. Amazing. Another thing with the horse, its eyes are over here on the side of its head, so that it can see at a distance, but when it gets its head down to graze, it cannot see what's in front of it. So it has a very sensitive upper lip with little hairs and some other sensitive arrangements, and that horse can use that upper lip to selectively pick a certain grass. Maybe there's a clump of grass right here and another clump of grass over here, and it likes the taste of this grass more than this grass, but it can't really see either one because they're right in front of it. It can use its upper lip and decide, oh yeah, that's the grass I like, and it'll take that. It can separate grain. It could separate like oats from corn. So they have been designed with this very intricately balanced way of, if I can't see it, I still know what it is because I have this sensitivity built into my mouth. Their teeth, when they get older, the teeth keep growing and they fan out. And so the older a horse gets, the longer its teeth get. And so people can tell a person that knows a horse, usually they'll look in its mouth first just to see what condition that the teeth are in. I think the oldest horse was about 62 years old, and the average life is about 25 years. But if a horse lives to be 62 years old, I wonder what its teeth might have looked like at that point. Being a dentist, probably looked like it had bad periodontal problems or something, I don't know. So where do we get that expression, long in the tooth, meaning like me, I'm getting older, okay? Martin, you're long in the tooth, okay? Well, that comes from people who have looked at the teeth of a horse, and they get longer as they get older, and the older they get, the longer they get. I don't know how my teeth are doing, but anyway. They're therapeutic. There are horses now being used for counseling for young people that have, maybe they're aggressive, they're angry, maybe bitter, and the horse seems to reflect the emotion of the person. And so these young people will be put next to a horse and kind of mated up with a horse, so to speak, but the young person's all full of tension and anxiety and anger, and the horse will back away. And these young people, well, no, I want that. I want to be friends with that horse. And they're teaching the young people to exhibit self-control, to control their emotions, because they want to be friendly with the horse, but when they have these bad vibes that they're shooting out, the horse senses that and won't get near them. And so they're learning how to exhibit self-control and having a happier, more joyful type of an attitude, and the horse will be more friendly. So in a therapeutic way, they're using horses. And of course, anybody that owns a horse knows it's therapeutic. Just go out and talk to your horse a little bit, or jump on and take a little ride. So horses are, I think, a gift of God to us to just enhance our life.
Now there is an egg. This is the largest egg in the world. Naturally, it comes from the largest bird in the world. Now compare this egg to this egg. This little egg comes from a hummingbird. Pretty big difference, huh? This shell is so strong that it can hold the weight of a full-grown man. And if you wanted to cook it for breakfast, you would have to boil it for 2 hours. The bird that produces this remarkable egg lives on the hot African plain and can go as long as 40 days without food or drink. Meet the incredible ostrich.
The ostrich is the largest bird on planet Earth, thought to have evolved from some sort of a large bird that used to fly, but it has a lot of size here compared to a hummingbird. Matter of fact, the eye of an ostrich is the biggest eye. It might be the biggest eye in land animals, but there are some little birds like hummingbirds that aren't even as big as the eye on an ostrich. So you have birds varying in large amounts in size and in abilities. A flightless bird like the ostrich, well, then why does it have wings? Well, it uses its wings. It's not that there's some vestigial organ left over from some bird that used to fly. It has uses for those wings. It uses it to scare its enemies. It'll flap those wings and scare its enemies. If it runs fast, and they can run very fast, up 35 miles an hour and more, they use those for brakes. They'll hold their wings out so they can stop more. They use it for air conditioning. They'll hold them up and flop them, and there's certain kinds of blood vessels that circulate through the wings that they can cool down their blood with their wings. So the wings are not useless wings. Their feathers have no oil. Most birds have lots of oil in their feathers, and yet the ostrich doesn't. Well, that's really helpful for the desert conditions. It's really designed for harsh conditions, and in the daytime it gets very hot, and so they have feathers that let the air circulate through them because they don't have oil that holds them together, and yet at night it can get very cold. Well, they have little muscles that control all of those feathers, like all birds do, and they can squeeze those feathers in and or fluff them out a little bit, and they act as a good insulator on a cold desert night. Another fascinating thing that they've discovered about the ostrich is that it has the most powerful immune system of any animal, and it would require a lot more study. Why does it have such a powerful immune system? What is it about the ostrich that gives it that powerful immune system? But ostriches, they just don't get sick. They are so healthy. They can be exposed to various types of things that other birds, it just almost wipes them out instantly, but it doesn't seem to affect an ostrich. So I believe God has built into the ostrich some things that maybe some bright young people could discover that would be helpful to mankind there too, as far as what makes a good immune system, what makes a powerful immune system, because the ostrich it has it. An ostrich is powerful with its kick. And some of the literature says that an ostrich with one kick can kill a lion, and it knows how to kick a lion so that it can kill it. Well, where does that information come from? Because, I mean, it's not going to be learned information. If the lion eats the ostrich, it's not going to learn how to kick it. So it had to have that information somehow put into it so that it knows what to do. If a lion or a cheetah tries to catch it and eat it, then they have that nice long neck so that they can have a nest down in the grasses, and they can put their head up and look, and they don't bury their head in the sand. We see that all the time, but they do have a behavior where they will stand and kind of put their head down on top of the ground and So there is a behavior where they do that, but they don't bury their head in the sand when danger is coming along. The ostrich has only 2 toes on its feet. Most birds have 3 or even 4 toes on their feet. And where does that come from? One of the toes has a large hook or large claw, which they use. That's their defensive weapon, is using that particular. So they know how to strike and do damage with that claw. And yet they can balance a big bird like that. As a matter of fact, people ride ostriches, and they have ostrich races over in sub-Sahara areas, and which I guess sound like fun if you like to do that kind of thing. They have had ostriches that have pulled carts and things like that. So they've been trained, so they're apparently intelligent enough that you can train them to do certain little tasks, and they guide them by pushing on their neck, and they have various ways to do that. So it's a fascinating bird. What a unique, different creature the ostrich is.
Did he just say the ostrich could kill a lion with a single kick? Wow, that is one powerful bird. Did you ever think what would happen if the ostrich needed time to develop this defense ability over hundreds of years like evolution teaches? Keep in mind what we just saw. The ostrich is grounded. It can't fly, and it's living on the African plains filled with hungry predators like lions, hyenas, and jackals. So if the ostrich couldn't defend itself, what would happen? It wouldn't last 5 minutes. It would be breakfast for some other hungry creature, and that would be the end of the ostrich. The poor ostrich wouldn't even have a chance to evolve.
You look at the animals, and you can't have a partially functional liver or pancreas or lung. It either functions or it doesn't function. And I was taught in evolution, if you don't use it, you lose it. All right, well, how do you use a partially formed pancreas? You either have to have the whole thing there with everything working, or it doesn't work. Now, some people bring up, oh yes, but what about the appendix? We don't really need the appendix. Well, yes, we do. These things called vestigial organs they're supposed to be leftovers from our ancestors. It was like 180 vestigial organs. We were told, oh, they have no function at all. Well, now they found functions for all of them. You have your appendix taken out. Oh, I don't need it. You see, God made a mistake. I don't need that appendix. Well, maybe not so much as an adult, but when you're a little baby, you need that appendix. It's part of your immune system. So we need all of our parts. God made them all. They all have to work in harmony with each other. How do you get that with just mindless, random chance processes? Over how many billions of years would you need? It's impossible. There would not be enough time, let alone the information needed to make those things work like they work.
Well, we've met the ostrich, the biggest bird in the world. Now I'd like to introduce you to the smallest bird in the world, the hummingbird. Some of these little guys are tiny, only 2 inches long if you measured them from beak to tail. But don't let the hummingbird's small size fool you. These little birds have some really big talents. They can really fly. Just look at them in your backyard and you'll see what I mean. Oh, there's one.
The things about hummingbirds, and all hummingbirds, they can fly frontwards, backwards, they can fly sideways, they can go up, they can go down, they can hover. They're the only bird that can do all that. Their wings are hooked on differently than other birds. They go up to something like 200 beats a second at times. And they're kind of like the dragonfly that we talked about on volume 2, that it can fly in every which direction too. So we have an insect that can fly in every direction. Now we have a bird that can fly in any kind of a direction. And a hummingbird isn't like other birds. Most birds, when they take off, they have to shove off with their feet. A hummingbird, it can wake up from its torpor condition overnight, and then all of a sudden, it decides time to take off with one flap of the wings. It doesn't even have to. It's so powerful. Just one flap of the wings, and it is almost full speed ahead. And they can fly really rapidly. Matter of fact, during the mating season, when the male is trying to impress the female, he will start buzzing his wings. This is when they're going maybe 200 The wings will be beating at many, many RPMs, and it makes the hum sound. That they got their name, hummingbird. And that's when he is trying to impress a female. His wings are, that's not the exact sound, but they make that sound. The hummingbird gets its name from that sound. Some hummingbirds, their beak is made for a particular flower. So their beak has a particular shape to it, a particular curve or a certain length, so that it can reach in to a certain kind of flower. One hummingbird has a beak 4 inches long, and the tongue in a hummingbird is almost like a tube, and so it has a pump, and it'll pump that nectar up out of the flower. The hummingbird they're some of the most colorful birds that we have, and their color, though, doesn't come from pigment. God has made the hummingbird with like a scaly type formation of its feathers, so that the light is refracted and reflected through that, and out comes all these colors. So maybe at night you would look at a hummingbird and it would kind of be just drab, but that you get the daylight and the light shining on it and all these brilliant colors come out. Another thing about them at night, their little metabolism is just going a mile a minute here all day long, and they have to eat almost constantly all day long because they burn so much energy. But then at night when they go to sleep, if they didn't go into this condition that's called torpor, which slows their metabolism down, slows their heart rate way down, slows their body temperature, cools down their body temperature so that they're only a couple degrees above outside temperature, whatever it is, and then they sleep that way. Well, then they're not burning a lot of energy at night, because most flowers close up at night, and they just don't go looking for flowers at night anyway. But if they didn't have this particular way of protecting themselves at night, they would like starve to death overnight because of this rapid metabolism. And yet, hummingbirds migrate. And many times they'll migrate with the flowers. As the flowers are blooming and they're going farther north each year, the hummingbirds go right with the flowers. Some hummingbirds will go and fly all the way across the Gulf of Mexico. Well, that's like 500 miles. You have a little 2 or 3 inch long bird that normally is eating all day, every day, and now all of a sudden it takes off and it's going to fly 500 miles, and it can't rest, it can't land, it's going to fly that whole distance. Well, how does it do that? Well, I haven't been able to find any researchers that really know how it does that. There's different theories about that. I think this is another area we could use some young people to, let's figure this out. How does something that burns energy rapidly, then with still using a lot of energy, conserve energy as it's flying across the Gulf of Mexico? And so there's some mysteries here built into the hummingbird too that I think deserve some of us to take a look at. Of course, a hummingbird is so tiny that they make a tiny nest, and they can make a nest in a matter of hours. And sometimes they do, but usually they'll work on it a day or two, and they make the nest. And sometimes the nest it's only about the size of a quarter, a 25-cent piece. The eggs about the size of a small pea. It only lays 2 eggs, so it'll have those 2 little eggs. But it's interesting how they get the material to make their nests. They'll use little bits of grass and sometimes some twigs and things. How do they hold it all together? They go and get spider webbing. And then different kinds of hummingbirds will make different varieties of nests. And of course, if you know hummingbirds and you see a nest, then you'll know, well, that's the hummingbird. But some of them, their nests are just hanging off of limbs, little twigs and things, and it's not balanced right. So they will go and they will pick up little pebbles, and with spider webbing, they'll hang pebbles on the side of the nest to balance the nest, so that when the bird is in the nest on the eggs, these stones act as a balance, so that the nest hangs more, straighter, as well as it doesn't rock as much in the wind because of the weight of the pebbles hanging on it. Well, how big could the brain of a hummingbird be? You know, this little tiny creature. And it has the knowledge to build a nest, first of all. It has its own kind of nest that it's going to build. And then it knows how to balance a nest by certain weights that it hooks in there, that seems like a design feature that would require information put in there so that it knows what to do. And I believe our Creator is the one that does that with the hummingbird.
Bring me the stick. Come here. This is my buddy Hudson. He's a great dog. He's a Hungarian Vizsla, which means versatile. This breed of dogs is a very versatile hunter. There's over 700 varieties of dogs. People love them because of their loyalty, their intelligence, and they're just so loving. Aren't you, buddy? Aren't you, buddy? The incredible dog remains one of the most loved animals in the world. It's no wonder their nickname is man's best friend. Isn't that right, Hudson? Isn't that right? Mwah.
What an amazing animal the dogs are, and what a friend they've been to mankind down through the years, and helper, and they help in so many ways. We have farm dogs that they'll go out there and learn how to herd the cattle or herd the sheep and guard the sheep, or then we have dogs that hunt and they can point and, hey, over here's a pheasant, and alert the hunter to, and then they'll freeze, and they lift a paw and put their tail up, and then we have just house dogs that you can train. So there's such an enjoyment, and it's one of the things I think God has given us for enjoyment. And then dogs have rescued people, and dogs can smell. Some of the literature says they can smell 1,000,000 times better than we can smell. Like bloodhounds, where they can trace a person walking through a crowd. They can follow the footprints. There's dogs that know a tornado is coming, and they can alert you to that before it ever drops out of the cloud. They just somehow know it's coming. Or other dogs have the ability to sense or smell people that have drowned, or maybe they aren't even quite drowned yet. They can be resuscitated. They're down under ice, down under feet of water. In the woods, there's dogs that can smell your skin cells that have maybe got you scratched on a bush and a little bit of you is left there. Even as much as a year later, they can track these things. We have dogs that are used, service dogs, to help people, to help the blind, the seeing eye dogs. There's one dog that has learned how to sniff a melanoma, a malignant mole. And you can have different things on your body, and that dog will start sniffing, and boom, right there. Even before the physicians can diagnose it, the dog knows that is the bad mole, and that's the one. And so they'll take that mole off and study it, and yep, sure enough, that was a bad mole. That was a cancer. And then we have other dogs that can sense when a person is going to have, for instance, a convulsion or a seizure of something, like in epilepsy. And the dog will know 2 to 3 minutes before that's going to happen, before the person knows, it's about to happen. The dog already knows. And the dogs will come and they'll sit down, and sometimes they'll even tap with their paw and bark, and a certain kind of bark, and that alerts the person, I'm going to have a seizure. And that gives them a chance to go sit down, or if they're driving a car, to maybe pull over and stop. How does a dog do that? Some people say, well, you can really see evolution in action when you look at dogs, because we've got these St. Bernards, and we've got these Great Danes, and we have these little tiny poodles, and that's not evolution. Let's say Noah's Ark, and I believe that's a real event, but let's just say Noah's Ark, he takes 2 dogs, or maybe 2 wolves, or 2 of the canine kind, and they come off the ark, and they have all this genetic material in them, and then they're selectively bred down over the years until they finally get down to a poodle. Well, a poodle is not evolution with new information that's been put into the genes. A poodle is a dog that has been selectively bred in such a way that information has dropped out. So you might be able to take 2 brown Mongolian dogs, let's say, and over the years breed them down to a poodle. But you can't take 2 poodles and breed them back to a brown Mongolian dog, because information has been lost. So that's not evolution, that's just selective genetic engineering, if we could call it that. There's no input of information, there's a loss of information. The dog that has all wrinkles in its skin, a Shar-Pei, they bred that dog in such a way that it still has the gene for the skin of a big dog. So the skin is bigger than the dog. And so here you have a smaller dog in a big dog genetically in a big dog's skin. And that's why it has all those wrinkles. And so you can do interesting things by genetically manipulating what's already there in the dog genes, but nobody has added any information in to give us a whole new kind of an animal from a dog. Dogs still give birth to dogs. And the dogs that it gives birth to, down the line, they can't go back and be a different kind of dog like they used to be, their ancestors were. They have to just keep going from there because information has been lost.
Yeah.
What an amazing, wonderful creature dogs are.
What's that, boy? What's that? Oh, Hudson just told me that he thinks dogs are the most incredible creatures of all. Speaking of dogs, there's an enormous sea creature with a dog-like face. It's on the endangered species list because there are only 2,000 left in the United States. But don't let its huge size scare you. This gentle giant is almost as friendly as Hudson here. Isn't that right, boy? If you travel up some of Florida's waterway inlets, where the freshwater underground warm springs flow, and meet the salt sea, you may stumble onto the giant manatee. Dive with the manatees, and you'll notice the waters are warm. Manatees are very sensitive to temperature, and they need warm water to survive. If the water temperature falls below 68 degrees for very long, the manatee will die. This unique creature is sometimes called the sea cow, and manatees have gained quite a following in Florida, as people have discovered how friendly and social this huge creature really is.
They look kind of like a dog in their face, although the evolutionists say they look like an elephant. And they will say, there used to be elephants, and I guess the elephants decided to go back in the water, and they became manatees. And some even say they come back and forth. For a while they'll live in the water, and then they'll come back out. But they do have a few characteristics like an elephant. On their front flippers, they have like toenails that look kind of like the toenails on an elephant's foot. And their mouth, they have a very sensitive mouth, but it has, like an elephant's trunk, has the little fingers that can grab things, and the mouth, with its very sensitive whiskers, can get out there, and he can feel different things that they're eating, and they can arrange it, and they'll even hold it sometimes in their flippers. So they almost look, well, they use their flippers almost like hands many times, which is fascinating to see a big sea cow that do that kind of thing. And they have this wonderful big kind of a flat tail, and when they swim, the tail, it just kind of gently pushes up and down like this and glides them through the water. It looks like this big submarine coming right by as they swim by. They guide themselves with their front fins. It's not like they're just working the same way. It's like they have a brain going to each one, and they can use one at a time, and they can move it different ways, and they can poke around with one, and they're intelligent. They're very intelligent. They don't have hair, but they have whiskers. And the difference between a hair and a whisker is, with a whisker, there are nerves attached. And some of the whiskers have as many as 4 different nerves attached that can tell the manatee different things. So it can sense food, it can sense different types of objects that it might want to not swim into, and many researchers believe that it can do that using these whiskers. They breathe through their nose. Most of the mammals that are underwater type, sea type creatures have the blowhole, like the porpoise and the whale, but the manatee, it breathes through its nose. And they can hold their breath a long time, and they can exhale almost everything in their lungs. It's like up to 90%, just all at one time. They'll come up and they'll blow out their air. It's like, whoosh, and out it goes. Sometimes they'll sleep on their back too. They'll drop down to the bottom and they'll sleep, and their heart rate can drop back to almost nothing when they're sleeping. And some researchers will tell us that it's one beat every 15 minutes, that's amazing. But even during their sleeping times, their breathing is much longer in between times when they have to breathe. So it's like their whole system just slows down. Well, how would that happen? By accident. And that's what they really need to do if they're going to sleep. Otherwise, they'd have to be coming up to breathe every 2 minutes or every 3 minutes. They have the best immune system, probably, of all the different types of mammals. These wonderful creatures are constantly being damaged and even killed by motorboats and the propellers just whacking them all up. And they have discovered that some of these, they heal up, even though they should be dead. You can see on their backs where propellers have just ripped them up, and some of their tails are kind of shredded. So the scientists have studied their blood. And some of the scientists say they have up to 90% white blood cells. And those are the ones that fight the disease. And so there maybe are some things here that we could learn from the manatee that would be helpful to us with especially now with all these immune deficiency type diseases that mankind is encountering. Maybe some young person could get his PhD in manatee blood and figure out what's going on here and help and be a tremendous help to mankind and improving our immune system. And so it has these amazing abilities. Evolutionists teach that elephants went into the sea and became the manatee. If manatees are some sort of an elephant that went into the water, as the evolutionists teach, then there's big questions that come up. Why aren't there some intermediate forms here between an elephant and a manatee? Why do we still have elephants if some elephants decided to go back into the ocean? We have manatees, we have elephants. We have nothing in between. We still have both of those. We don't see any manatees trying to come back out on land. We don't see any elephants deciding, I think I'm going to head into the ocean. I don't know how we can think like that, other than that God just made a manatee, and God used that particular form of an animal, a discrete entity, like an elephant is a discrete entity, and we talked about those in Volume 2 of Incredible Creatures. They are discrete. They have specific things that are very, very peculiar to them. The manatee has things very peculiar to it, and we have nothing that would bridge the gap between the two. And so it seems to me that looks more like two particularly fascinating created entities here, even though they appear to have some relationship with their appearances. Let's have some proof. Let's have some evidence. I used to accept things just by faith that I was taught, and now I just look for the evidence. All right, let's find some evidence here. And there isn't any right there, because we've looked pretty carefully at that.
New boating rules are now in place to help protect the manatee from prop damage. So hopefully, the manatees will be around for years to come. And hey, if the evolutionists are right, maybe one will crawl out of the water and become an elephant again. One of the most welcome insects in the garden is the butterfly. They are gentle, beautiful creatures and often photographed for their stunning colors. Children and adults both collect them. Nice one. Some of the largest population of butterflies are from Central and South America. Some are tiny, just centimeters long, and other butterflies have recorded wingspans of almost 12 inches. Look close at the butterfly, and you'll see that it's obvious this little creature has been designed. Butterfly color patterns are so intricate and beautiful that they rival the world's best painters. But interestingly, these amazing colors do not come from pigment. So where do these colors come from? Tiny little scales in each of the butterfly's wings are designed to reflect and refract different kinds of light. Like light through a prism, each ray of light shines through the scales, creating a stunning color show. So without light, the butterfly has very little color. But with light shining through the prism of its scales, it becomes a kaleidoscope of color. So get up close to a butterfly, and you'll discover another incredible creature.
the butterfly has one of the most interesting life cycles, I think, of any animal, because first of all, you have the egg. Now, there's a study needs to be done, a photographic study of the eggs of insects, because they're all different. There are many different colors. Some of them are just a speck, but you magnify that, and they have brilliant colors and shapes and textures. Every egg is different from every different kind of an animal. Almost no studies have been done on that. There's a good study for a young person, but in any event, you have the egg, and then let's say we're going to talk about a monarch butterfly. Well, they're going to put their egg on a particular leaf. They like the milkweed plant. And so they put their egg on the kind of a leaf that when the egg hatches and you get your caterpillar, the caterpillar wants to eat. Well, most caterpillars, that stage of the butterfly life, are engineered to eat only one particular kind of leaf. Like the monarch likes the milkweed leaf. So if the butterfly puts the egg on the wrong kind of a leaf, they'll die of starvation. It'll eat the egg, what's left of the egg, the shell. It has lots of protein in it, and that gets it started. So here's a little mystery. How does the butterfly, each different kind of butterfly, know exactly what leaf or what plant to put their eggs on? It has a digestive system designed genetically to handle that type of food. So it eats these leaves, and then it grows, and some of them get large, and then it gets a certain size and a certain amount of time, and it decides, oh, it's time for me to go into my pupa or my chrysalis form. And then it like dissolves down into a mucousy, viscous, kind of a slimy material. And if you just looked at that, you would say, well, that's not alive. That's just a bunch of dead mush here. But it's alive. And it has a certain genetic bit of information going on it, which is different than the caterpillar had. So now we have like genetic information number 2 system. And while it is in this chrysalis form, a lot of things are happening. And that slimy matter in there is making itself into a butterfly. There's a name for that, and the name is metamorphosis. It comes from the Greek term. So a butterfly goes from being this caterpillar into the chrysalis, which is like nothing, and then in that, somehow another genetic system takes over, and here emerges a beautiful butterfly. When the butterfly is getting ready to hatch out of the chrysalis, the hard outside layer, it begins to change color. And it goes from a dark color to it's almost transparent. And you can actually see through that, and you can see the beginning colors in the wings of the caterpillar inside of that. And that, once that really begins, it only takes about 12 hours or so. But then when the butterfly just completely breaks out of there, that's only a matter of about 2 minutes. And here it comes, and it emerges out like a miracle from that slime. Look what we have now. And then, of course, it can't fly immediately, so it has to get itself ready, and its legs are kind of have to unfold and come out. Its wings are all tied up, and then it starts pumping blood into the wings and expands the wings, and the wings will dry out. But it has to be 80 degrees or above for the little butterfly to fly. And then it knows, oh, I can't eat leaves anymore. It doesn't go over and try to use its proboscis to start chewing on a leaf. Now it has the genetic information to digest nectar. It knows I need to go to a flower and stick my nose or whatever it is down in there, and I'm going to drink the nectar. How does it know that? That is information. And evolution has no explanation whatsoever as to how you can put information into a system. Chemicals don't have information. They're just chemicals. How does it know where to go and what to eat? Where to go? There's a good question. How does it know to fly? I mean, it has been crawling around on a plant as a caterpillar, and it didn't fly. Didn't even think of flying. But now it's a butterfly. Why doesn't it just keep crawling around on the plant? How does it know, I'm now a butterfly. I can fly. And then it takes off. How does a monarch butterfly know where to go when it flies almost 2,500 miles from Canada down into Mexico for the wintertime or in Southern California? Somehow they tag some of these little things. I don't know how they do this, but they've traced some of these butterflies. These monarchs migrate up to 2,500 miles, maybe a little more than that. How does an insect know, okay, it's time for me to head south? And then it knows where to go, and it knows how to get there. How does a butterfly fly into the wind? We ask a flight expert that's an insect flight expert. How does a butterfly fly into the wind? I mean, we had a 30-mile-per-hour wind coming across our backyard one day, and here comes this butterfly, and it's flying into the wind, but its wings aren't going bzzz. It's making headway, but it's like it's up here, and it's down here, and it's over here. And can a butterfly find pockets in the wind where there is no wind? What kind of a sensory apparatus does it have in its head that it knows, oh, I better get out of here, better get down here? And in the way they fly, there's some mysteries that maybe would help us with flight if someone could figure that out. Just thinking about a butterfly and all that it goes through to become a butterfly, through those 3 stages with different genetic makeups, it is a delightful, thoroughly educational, beautiful piece of artwork that our great Creator has done.
Butterflies are so beautiful. They are art in flight. They are design on exhibition. It's amazing to think that anyone could believe that something so gorgeous as a butterfly could happen as an evolutionary accident. Check out this car. This is the Jaguar XJR. Oh, so sweet. A mere $82,000, but it is loaded. Supercharged, liquid intercooled V8 engine. She generates nearly 400 horsepower. That means she's fast. Faster than a Corvette. When you drive the XJR, the enhanced self-leveling air suspension system automatically lowers the car's ride height at higher speeds to enhance stability and aerodynamic efficiency, making for an amazing driving performance. Just one of the amazing features that makes this car one of the most impressive in the world. It's obvious that this car has been designed, each part created to work together perfectly, so I can travel from one point to the other in style. Wish it were mine. What a ride. No one would ever believe that a beautiful car like this happened by random chance or was a product of some cosmic accident. Why, that would be an insult to Jaguar's fine car designers. But somehow, when it comes to animals, nature, and you and me, some insist on believing that it was an evolutionary accident that created all we see around us. Sadly, even after all we've learned about these incredible creatures, Darwin's theory of evolution continues to be taught in our schools as scientific fact. But is the theory of evolution science? We put that question to Dr. Martin.
What is true science? See, there's 2 different kinds of science, really. There's what's called operational science or operative science, and there's what's called forensic science. Now, operational science is what we can do in the lab. We can do it, and I can do it, and you can do it, and we'll mix the same things together. We'll come up with the same results if we do it right. But then you have forensic science, and that is really what macro Big Bang type evolutionary science is. Because what are we doing with that? Well, we have some clues. We have some fossils. And what's a fossil? Well, it's a dead creature. So you have to get it to life before it can become a fossil. So that they're really stopped right there. But let's say we have the fossil. Well, what does that tell us? Well, it doesn't really tell us anything, except when you look with your worldview glasses and you're looking through your worldview and you've already decided, I think the universe is old. Well, then you're going to interpret the information, whether it's a fossil or a living creature, that has to be old. That has to be a process here. But if you look through, let's say, biblical worldview glasses, and you are already, one of your assumptions is this universe is young. The Bible teaches it's young. Then you're going to interpret the information that way. So really it's a worldview situation here with using forensic science calling it science, because the textbooks do, but that's really not an accurate definition of true science, because true science, and most textbooks have the definition of true science in them. It's reproducible, experimentally verifiable type situations here, and you can't, nobody was there. How can you reproduce the Big Bang? You can't do that in a laboratory. What we can do in a laboratory is prove that explosions seem to tend to make things more chaotic, not more ordered. I don't know of any explosions that you can make things get better with an explosion, okay? So there's all these unexplainable things because we're basically looking at calling something that's not really science. Actually, it's really speculative philosophy. When we're talking old universe, Big Bang type things, that's really it's metaphysical naturalism is another word for it. But it's an idea, and ideas have consequences.
Some creatures are so strange, so different, so bizarre. It's like they're from another planet. Here's a creature that most of us will never see. And once you check it out, you'll be glad.
There's a little sea creature called the cuttlefish, and many people have heard of cuttlebone, which you might have in your bird cages at home. But this little creature, they get to be about a foot long, the average one, but yet some of them off the Australian coast get to be up to 3 feet long. But they're amazing because they have a skin that is completely different than anything other than things in their same family, which would be things like the squid or the octopus. They can change the color, the texture of their skin in like a split second. Just like that. I mean, their whole body can go from red to green, just like that. And they have these different types of little sacs. They call them pigment sacs, and with muscles around them. And these tiny little things, when the muscles contract, they squeeze the sac up in such a way that it turns a certain color like a little disc. So their body is just completely covered. They're called chromatophores, with these little discs, but they can make them appear in different colors. And then they have different types of color mechanisms. They have one, they're called iridophores, and those reflect light. So they're using the same types of reflection of light that perhaps a butterfly wing does when they reflect light and show the colors. And then they have others called leucophores, and the leucophores are the white ones, and they have little white dots all through them. So that some of the colors that they make, they're mixing different mechanisms to come up with the color they want. Incredible, just incredible. And they have emotions. They'll get angry. And when they get angry, they might turn red. They'll turn their whole body red, just boom, just like that, and they're red. And then maybe if they get fearful, they'll turn a green or a yellow, or they might just drop down to the ocean floor and turn the color of the sand. Or they might even have little papillae, little things that stick up on their skin, and they'll mimic a rock. Or sometimes they'll even mimic kelp, like they have these 8 tentacles here in front in their face, and they will move them to shape and turn them green, and they'll just float along with the kelp. They have what's called neutral buoyancy. These little animals can actually pump gas or water into their bone. And so if they want to hover in the water, they take a certain amount of water out of their bone or put a certain amount of air into their bone, and they can stay here. Or they can squirt the water into the bone and just drop down quickly. And they think, they actually can think, and they can see very well. Matter of fact, they have a pupil. It's like a W-shaped pupil. It almost looks like Batman when you see a picture of their pupil. And that pupil, they have binocular vision. This strange-looking little creature, and its eyes can focus in on one thing. Both eyes can focus together like we do as humans, and so they can spot their prey, and then they want to come up here and they want to kind of confuse their prey before they eat it. So some of these have the ability, it's like they turn on strobe lights on their head. And here comes these lights. It almost looks like the old movie theaters that had those lights that went all the way around. Here they go with these lights. And what they think they'd like to eat is looking at that thing, and it's oh my, what is that? And it almost hypnotizes them. And they turn on all their mechanisms and start shining their lights. And what might this other thing be thinking that they want to eat? I mean, it looks like a UFO or a extraterrestrial or something just coming in there. It has two flaps of skin here on the sides of its head, and hidden under that are two long tentacles, but they're different. They're feeding tentacles, and they blow them out like at a party. You get those little things you blow and it goes out. Well, that's what they do with these. They just blow them out and catch their prey, and it's just in an instant, whoop, and they get it and they bring it right back, and then the tentacles grab it, and then they can feed themselves. How does all that happen on what looks to be like this primitive creature? Can we, through evolutionary science, first of all, explain how this thing could do this? Where did it come from? Where is it going? Why does it have these abilities that it has? They think, and they see, and they come to conclusions about things, and they know how to stalk their prey, and they know when is the right time to turn on the lights or to shoot out their tentacles that grab the food. They're making decisions. How can we explain that through mindless, random chance processes? I can't do it. Personally, I can't do it.
All right, we are here. Our next animal is a really sharp dresser. In fact, he always looks like he is ready for a night on the town. We're talking about penguins. They are dressed to impress, and they're a favorite attraction of wildlife tours and zoos everywhere. Penguins are just cute. They walk upright, are playful, innocent, and so entertaining. They have got to be one of the most unusual birds in the world. Did you know that penguins only live south of the equator in the Antarctic? There are none in the North Pole. Unusual. Anyway, penguins range in size from little ones about a foot tall to the emperor penguin, which is about 3 feet tall. However, fossils have been discovered of emperor penguins, which are over 8 feet tall. Imagine meeting one of those on a walk. When the cold season comes, most animals want to head to a warmer climate, but not the emperor penguin. He will head closer to the South Pole, into the cold. The emperor penguin is about to undertake a Herculean task to lay their egg and raise their young in a climate that is one of the most forbidding on the planet. It's an achievement that is nothing short of incredible. So what are you going to order?
The female will lay an egg, puts it on the male's feet, and then the male keeps that egg on his feet, and he has an egg pouch that kind of goes around the egg, and it keeps that egg at 95 degrees Fahrenheit. Now we'd say, well, so what? Well, sometimes in the winter down there in the Antarctica, the temperature is 100 degrees, even more than that, below zero, with 100-mile-per-hour wind, which is an incredible wind chill, and that egg is only a couple inches off the ice, and that male penguin keeps that egg warm and keeps it on his feet. If he gets it off the feet, it'll freeze in about 2 minutes. So he has to keep that on his feet. Now, the female gives him the egg, and then she takes off. She's gonna go eat. So she walks across the ice pack, and sometimes at this point the ice pack may be 30, 40 miles long. and she has to walk out there. She goes off into the ocean, and she will be eating and feeding in the ocean for 2.5 months. And meanwhile, here's Daddy Penguin, and he's taking care of the egg. But he can't eat, and he doesn't drink for up to 2.5 months. He loses up to 40% of his body weight while he's taking care of that egg. That's his main function. I mean, you think standing for 2.5 months on an ice pack with 100 below zero, 100-mile-per-hour wind chill, and their feet don't freeze? I mean, that's a miracle in itself, the way God designed that. All right, so Mama's out there feeding. Daddy's taking care of the egg. It's 100 below zero, and these penguins live in huge flocks. And so what the male does is, he will be on the outside of the flock where it's cold, and he puts his back to the wind, and he starts to get cold. I gotta warm up. So he starts moving in toward the center of the big flock. And then other ones will move from the center out to the outside. So they keep rotating out. And so none of them freeze. They know, okay, now it's my turn to go out and get cold for a while, and my turn to go warm up for a while. And they do all this. Now here's Mom out here swimming and eating. And all of a sudden, at some kind of an unknown signal, she decides, oh, I gotta get back. My chick is almost ready to be hatched out. And so Mama Penguin heads back home. They're supposedly a bird that lost its ability to fly. Well, the evolutionists haven't come up with any ancestors for the penguins. So what kind of a bird was it that became a penguin that lost its ability to fly? But they really do fly, because they fly underwater. And you watch them in some underwater shots with their fins, and they just use those fins like wings underwater. And they can get such force that they can jump out of the water up onto an ice pack, and some can go as far as 30 feet. They come, boom, and they pop up out of the water and land up here. Well, now she's been out in the ocean for 2.5 months, sometimes even a little longer than that. And now it's winter, so the ice pack has grown. And so now maybe instead of 30 or 40 miles, she might have 50 or 60 miles of ice pack to walk across to get back. Well, now here's this whole flock of thousands of male penguins, each with an egg. How is she going to find Daddy? How is she going to find her mate? Well, somehow or another, and the scientists think that they understand the call. And yet you think about that. Here are thousands of male penguins, whatever they do to chirp. And here comes Mama Penguin listening for her particular male, and she can find her male. Now, here's one of the mysteries of this whole thing. More often than not, she goes back and finds her male on the very day that the chick is born. How can that be? She's got to walk over 50, 60 miles of ice pack and come out of the ocean and find where they are. I mean, you're thinking, well, this flock here, just how many? Takes up a couple football fields maybe, in all these miles and miles of ice, and yet she can find her male. She does it right on time. Now she has brought back with her partially digested fish from the ocean, and she carries them with her in her stomach. And now the scientists aren't exactly sure how she does that, so that the fish doesn't like rot and it doesn't really digest. It's preserved in a form that acts as food for the chick. Now, some scientists say maybe they have some sort of an antibiotic that they manufacture so that the food doesn't just rot, but they get it back. And now Daddy and Mommy Bird take care of the baby bird until spring. And now now that the ice is melting back, and they take the baby and they go swimming. These penguins spend most of their life in the open water, in the open sea. There are some of these penguins that are in the ocean 9 months out of the year. That means they have to sleep in the ocean, and nobody has observed that, which is an incredible thing right there in and of itself. They're also playful. They'll find an ice slide, and they'll slide down that slide, and they'll waddle right back up to the top, slide down again. So they like to play. Sometimes when you see penguins, it's almost like they're playing follow the leader. They just follow each other. Boom, 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 boom. Up they go. And what are they thinking? How do they decide who's going to be first? I think maybe the penguin is an animal that's just made for us to enjoy.
Your vanilla ice cream, sir.
Thank you. Vanilla ice cream. I love vanilla. Did you ever wonder where vanilla comes from? Well, if not for our next incredible creature, vanilla wouldn't even exist. Vanilla.
In Mexico, there is a little bee. It's a little tiny bee. It's not a whole lot bigger than a flea. It's a true bee. Doesn't have a stinger, but it is a bee. It's called the Melipona bee or the Melipona bee. And this little bee is closely identified with something that all of us have enjoyed from time to time called vanilla. And I will ask people, do you know where vanilla comes from? And they will say, oh yeah, the vanilla bean. And then we'll say, well, where does the bean come from? Well, it comes from a tree. Well, no, not really. It comes from an orchid. And the vanilla orchid grows up a tree as a vine. And here is the problem. The vanilla orchid only blooms one morning out of the year. Now, they don't all bloom on the same morning, but it'll bloom 2.5, 3 hours. And then by afternoon, it wilts and it can't be pollinated. But why is there a problem here? Well, because the vanilla bean pollen is covered with a little septum down inside the flower, so the pollen can't get out. And so God made a little bee called the Melipona bee that knows exactly what to do to pollinate the vanilla flower so that we can get the vanilla bean, so that we can have vanilla, which most of us enjoy. And this little bee will come up to the flower, and it knows how to land on the flower, push up the septum, find the little entrance there, and go in. And then when it comes out, it has pollen with it, and it'll go to the next one. And this little bee was made for the orchid, and without the bee, you just don't have the vanilla bean. Now, that came up way back in the day of Hernando Cortez. And Cortez, when he came over here, went to Mexico, liked vanilla, took some back with him to Europe, and then for 300 years, they grew vanilla plants. I guess they did it with cuttings because they didn't get any beans. So that was like 1519. In 1836, a man named Morin decided, I'm going to go to Mexico. I'm going to find out why they get the vanilla bean in Mexico. We don't get the vanilla bean in Europe. So he went to Mexico. He sat down with the vanilla flowers and watched them. And all of a sudden, one day, he hears this bzzz, and he looks, and there's that little Melipona bee. And he saw it land, lift up the septum, find the little entry point, goes in, and I now know why they get vanilla in Mexico and we don't get it. And so here comes artificial pollination. And then they started growing vanilla in the European areas, and they could get it because they had to artificially pollinate it, because that little bee is the only insect that knows how to pollinate that particular orchid. So the orchid and the bee are made for each other. They had to both be made together at the same time. Otherwise, in one generation, the vanilla is going extinct because there's nothing there to pollinate it if the little bee isn't there. But if the little bee doesn't have the information to know how to get into the flower, which other insects apparently don't know how to do that, well, then you still get an extinct flower. So they had to be made together. So I think that shows that our Creator has made these things in such a way that if we carefully study them, we're face to face with a dilemma here. Could this be an accident, or could this have been created like it is? And I think He wants us to say, hey, look at this. This was created just like it is, and then He gets the glory, and He gets the thanks for doing that.
Wow, that's amazing. Who knew? Without the Melipona bee, there would be no vanilla plant, and therefore, no vanilla. Thank you, little bee. Each of the animals we've looked at has been designed to function flawlessly in its environment. It's obvious that behind each creature is a designer. But who is genius enough and brilliant enough to design such wonderful creatures?
Well, we've spent some time talking about incredible creatures that defy evolution, and they really do. Everything we've looked at is created and designed. It has purpose, it has function, it has a coordination of so many things that have to all be there. They have to all be there at the same time. When we look at the design that we see in everything that we've looked at, everything in nature, from plant to animal to rock, There is design. Well, that seems to say to me there is a designer. If you have a design, you have a designer. If you have a piece of art, you have an artist. If you have a creation, you have a creator. We have a creation, we have a creator. He designed us so that we would fellowship with him. That's why he created us. That's why he designed us, so that he could have us to bring him glory and to fellowship with. And so he offers us this free gift of salvation through his Son that paid the terrible price of his passion. But then he didn't stay dead. He came up out of the tomb at the resurrection. So we have a risen Lord who is our creator and is our redeemer. And he loves us and he wants a relationship with each of us.
Well, there you have it. So the next time you're spending some time out in the beauty of nature, take a good look around. Every tree, every flower, every animal tells an incredible story. A story of design, of purpose, and of destiny. I'm David Hames. I'll see you next time. Come on, Hudson.
Boy, our Creator gave us a wonderful variety, and we get to study it, hopefully, forever. Let us pray. Heavenly Father, we thank you for this Sabbath day. We thank you for all the wonderful things that you created. We acknowledge you as our Creator, not only us, but all creation. Lord, bless us with this opportunity to listen and learn of your creation. Lord, give us mercy, travel mercies home, and bring us back in the morning. In Jesus' name I pray, amen.